Very much, Mrs. Williams. Thank you very much. Okay, so we went over some of those housekeeping matters, reminding you to make sure that you fill in the registration form, reminding you to make sure that students, you have your stuff to write, to make the notes, to make the jottings, you have that with you. So we will go right into things. So today we'll be looking at developing quantitative reasoning. Before we get there, just want to remind you what the quantitative reasoning is all about. Remember that your quantitative reasoning workshop looks at a number of things. We will look at patterns, we will look at problem solving, we'll look at comparing quantities, we'll look at representing quantities. These are some of the things that we will be looking at today because those are the main concepts that are looked at during the ability test for PEP 6. And as you do your quantitative reasoning in your test, as you do with any test at all, remember you need to read your instructions carefully. Make sure you read the question carefully, read the instructions for the test, you read the problem, the specific question for that problem. Check to see, because you're dealing with the quantitative reasoning, which is the second half of your paper, questions 21 to 40, you're going to be looking at what math concept have I learned? What math concept could this be asking me about? What math concept would be best applied in doing this question? You will apply that concept, do the math associated with it, and also important, check your answer. Is your answer a reasonable answer? Is your answer among the options that are present? Is your answer making sense? So you always want to check for the reasonableness of your answer. If I'm subtracting at your level, when I subtract, I should get a smaller value. You look out for little things like that. If I'm multiplying and I'm not multiplying, and I'm multiplying by a whole number, I should be getting a larger value. If I'm dividing by a whole number, I should get a smaller value. Little things like those you should be looking out for. So as you do your quantitative reasoning, think carefully as you work through your questions and you make your selections. So that's some of the main things that we want to be looking at. So the first thing that we're looking at in today's presentation, so we've looked at our materials needed, we talked about that. So you're gonna make sure you have your math book in place, make sure you have your pen, your pencil, and so on. And of course, an engaged brain. An engaged brain, ready to participate, ready to act. Be willing to also say, okay, if I made a mistake, I can learn from that mistake. So be engaged and ready to participate. All right, so we mentioned the session. So we're gonna start off looking at patterns. So let's look at a scenario here today. So your teacher, your classroom teacher, says that she's going to arrange the students to go into class with a pattern. She says she's going to do 2 girls, then 1 boy, 2 girls, then 1 boy, 2 girls, then 1 boy, and so on. That's the pattern that she has decided to use. So I want to ask, why do you call that a pattern? What is about that makes that a pattern? What is it about that makes that a pattern? Anyone would want to tell me, just type in the chat and let me know, what is it about that makes it a pattern? She says 2 girls, 1 boy, or 2 girls and 1 boy, 2 girls and 1 boy, and so on. What about that makes it a pattern? You could type it in the chat as to why you think that this is correct in calling that a pattern. The thoughts on it? It's repeating. It has a sequence of things. I see those responses in the chat. It's repeating, and it's repeating with the same thing each time. Okay, thank you. All right, let's the sequence is consecutive. So it's following a specific order. All right, I'm seeing several responses. Thank you for those responses. There's a repeating, alternating. I guess you mean that they're gonna go one thing then another, one thing then another. So sort of, I see what you're saying. I get what you mean with the alternating. So they will change positions and they'll still keep that repeating. But I hear a key idea coming out that is repeated. It's likely to be continuous unless you have a finite, what we call a finite sequence. So good. Thank you for that feedback. Now I wanted to quickly type in the chat. So another pattern that Miss could have used. Another pattern. Before we look at the shapes, another pattern that Miss could have used for her, using B for boy and G for girl. Could you just type in the chat quickly for me? Other patterns that Miss could have used for her students. This one was girl, girl, boy, girl, girl, boy. What are other patterns she could have used? For the boy and girl, not so much the shape. Sir, yeah, okay. So what other pattern could Miss have used? She has girl, girl, boy. Now what is typing B for boy, G for girl? Suggest another pattern that Miss could have used. For the boy and girl, for the boy and girl. I have BB, GG, but then hold on, I see some responses. So would BB, GG be, are you saying that you could have boy, boy, boy? So where would all the girls be in the class? It would be boy, boy, girl, girl. All right, so I'm not seeing the, so I see some responses there. So also you're saying it's an expanding pattern. Boy, boy, girl, girl, and three boys and girls. All right, thank you for that. Appreciate that. Girl, girl, boy, boy, boy. All right, thank you for that. So, thank you for that. So she could have chosen any pattern that she wants for her. She could choose any rule that she wants in order to create her pattern. So thank you for that feedback. 2 boys and 3 girls, 3 boys and 3 girls. All right. One of the things you have to be careful with is that there's enough place for you to develop that pattern. So depending on the number of persons that are in the class and so on, you decide on the pattern. Let's move to the one on our screen now. We have some shapes that follow a pattern. Tell me something that you notice about the pattern. I see some persons typing that what are some of the things that you notice about the pattern? Could you tell me some things that you see with the pattern that is on the screen? What are some of the things you notice? Based on what is on the screen, it follows a pattern. What are some of the features of this pattern that you can see? Just share in your chat with it. Whatever you want to talk about with the pattern, just type quickly in the chat what you see that you would observe that makes this a pattern. It repeats over and over. What is repeating over and what is in the shape? What are the things in the pattern? Let's start there. What are the things in the pattern? Are they all the same? Is there a certain number? Let's talk to me about the pattern. Okay, there is a pattern with shapes. Okay, the shapes are different colors. Fine. What shapes do we have? Type in the chat for me the shapes that we have. Yeah, see that we have the different colors. Other persons mentioned the different colors. I hear something about the shapes themselves. Is it the same shape that is each time being used? There are different colors. It's a pattern, so you must have repeated. So we have a triangle, then a square, then a circle. Is the same symbol repeated though? Do I have all triangles or all circles? Okay. So it's a triangle, then a square, then a circle. Fine. So we're seeing that. The shapes are different sizes. Yes, okay, I see that. So the square is very small. Not the square, rather. The triangle is very small. All right, so we have triangle, square, circle, triangle, square, circle. Fine, thank you for that. So based on this pattern, what, you can continue, sir. What would be the next 2 terms in this pattern? What would be the next 2 terms? You can move on, sir. Or who is, is Faith in screen or my, or who's on it? So which of the following is the next 2 shapes in the pattern? Is it option A, B, C, or D? I see several B's coming up in the chat. Thank you very much. It is indeed option B because we wouldn't have A because it doesn't, triangle doesn't follow a square. So that could not be it. Very good. Thanks for that. That's a good little warm-up one. B would be the answer in this case. B. Thank you. All right, so let's move on to another pattern. We're going to use the same shapes, but we're going to change it a bit. Here are the same shapes, but look at the shapes a bit more closely. Are the shapes the same size for each group of shapes? Are the shapes the same size for each group of shapes? Yes or no? Just type yes or no in the chat. Are the shapes the same size? No, they're not. So notice that each shape also increases in size every time it repeats. So we have small, then medium, then large, and we go back to small. So we have a different kind of pattern this time. It's not only shapes, but the size that is changing. All right, fine. So what do you notice about the shapes? As I say there, each shape also increases in size every time it repeats. So tell me some more now. Now that you see that the shapes increase in size, we have that information there that the shapes are increasing in size each time it repeats. So based on that, I will just ask you now. I see a hand raised. What you would like to answer? Let me hear what that raised hand is about. So describe a bit more what you see. Well, I've said some of what you see. But I've said some, maybe there are other things you have seen. Describe for me some of the things that you see. Some people saying they're increase, then decrease. Okay. It goes from smallest to largest. Right? What is going from smallest to largest? Okay, small starts from smallest and it goes to largest. Okay. So tell me some of the other things that you're seeing, please. Anything else? The shapes are going from smaller to larger. Okay, the shapes get bigger. Great. All right. I do agree with those statements that the shapes are getting bigger. One person says increase, then decrease. So they increase and then they decrease. All right. The pattern remains the same even as the size changes. So even though the sizes are different, we still have the same 3 shapes, the same 3 colors. So I see some hands up. Let me see what hands are up. I see St. Peter's and Paul hand up. All right, then let me see whose hands are up and who would like to. St. Peter and Paul, I see your hand up. Would you like to open your mic to answer? And let's hear some of what you want to share. Go ahead, St. Peter and Paul. What would you say would be the... Go ahead, St. Peter and Paul. D. And I'm not hearing. Is it B for boy that you're saying is the next one?
I heard D from St. Peter and Paul.
What did you hear, Mrs. Williams?
I heard D.
D, okay. I see a lot of persons are saying D. And okay, field prep says they increase in size, small, medium, large, goes from 4 small, 3 medium, and 2 large. 4 small, 3 medium. Could you tell me a bit more about that when you're interpreting the pattern? Could you share a bit more when you say it goes from 4 small, 3 medium, and 2 large? Let me hear a bit on that, please. Field prep. Why you've chosen D based on that rhythm that you have created? Is Hope able to unmute and give and share a bit about their response? Hope Prep is not responding. I wanted to hear a bit more about this discussion. That you have the increase in size, it goes from 4 small. I wasn't seeing the 4 small, 3 medium, then 2 large. I wasn't seeing that, and I wanted to share that discussion. But you're not responding, so.
Excuse me, Miss Harris.
Yes, go ahead.
It's
Hopefield Prep, I can see.
So
is that Hopefield
I
Prep?
noticed that.
Aren't we unmuted?
We're unmuted. Miss Harris.
Which
So I noticed that there were, when I counted, there was 2 small triangles, 1 small square, and 1 small circle, which is 4. Then there's
Excuse me, miss.
No, person wise, just a second, one at a time.
And then
Like you
there's
said,
1
there are 2 small
and 1
triangles. Go ahead, could you say that again,
circle.
please?
So it goes from 4 to 3 to 2. So in each, so the pattern is, it goes from big to small, and each time one shape is subtracted. I mean small to big.
Where did you
Are
get
you
the
hearing
force?
us? I don't think she's hearing us.
I'm hearing you and I'm
I'm
trying to
hearing
hear you.
you.
You said to me it goes from 4 small, 3 medium, and then 2 large. So
And
not,
then it,
where are the 4 small? I see 1, 2, 3 small. Where are the 4 small? Just gonna give us a little time.
Can you allow him to annotate the screen? Miss Harris, can you allow the student to annotate the screen?
I have to ask
Excuse me. Sorry. No, for this meeting, there is absolutely no
Okay.
annotation.
May I explain what he's saying? His observation
Go
is
ahead.
that
Let us hear.
in the first segment, there is a small triangle, a small rectangle or square, a small blue circle. Then the triangle increases in size, but it is still small in comparison to the other shapes. And then all the shapes increase in size, but one is removed. So it starts now with the black rectangle, which is a medium size, a blue circle medium, and a medium sized triangle. That's 3 shapes instead of the 4. Another shape is removed. It starts with a black rectangle, large, a blue circle, large. Then it goes back to the original small shapes where there are 4 of them. That's what the student is trying to explain.
Okay.
Remember, there are more than one ways to interpret these kind of diagrams.
Certainly. This is why I wanted to hear from your student what was in where the thought pattern was. Colleagues, any thoughts on that? Thank you very much for that contribution from Field Prep. So as you said, there are various ways that we can interpret the pattern. I wasn't quite seeing how one was removed, but I guess it depends on how you, the vantage point that you're looking from. So we're generally in agreement that it in fact is D. So anyone else had another perspective as to how you saw it? Thank you for that, Field Prep. Someone says it's going small, medium, large, and repeat. So Mrs. Williams.
I'm seeing a consensus in the chat, Miss, that D is the answer. So most persons, I don't see anybody
all in agreement that D is the answer.
Exactly. So I think they got the pattern. However,
so we got the idea that we're going from
it, they all got the pattern.
All right. So we're more or less clear that the answer is in fact D. So we start off with 3 small ones, and we move on to the 3 medium ones, then 3 large, and we go back to 3 small.
All right.
So our next one, we've got the next one will be a medium circle, then a large triangle. Okay, let's continue. Number 2. We have another pattern here. Here we have another pattern. Wanted to look at the pattern, the first 3 diagrams below. Each one follows a certain rule based on the first 3 diagrams. So you're going to use your first 3 diagrams to guide you to see if you can determine the rule being applied. And then from those 3 diagrams, determine what would be the A. So we've moved on. We know the answer is D from the previous slide. We've moved on to another pattern. So we're not ready yet. Give yourself some think time and decide on what is the pattern or the rule that is being applied here, or the rule being applied to create the pattern. Let me put it that way. So we have some hands up. Go ahead, St. Andrew Primary. What are your thoughts? Let me hear what you're seeing on that. St. Andrew Primary, I'm not ready for the answer yet. I just want to hear what the rule or the pattern first, please. Can you explain to me what you noticed, St. Andrew Primary?
What we noticed is that whatever is added is multiplied. So the
Okay.
answer would be 21.
Okay, okay, thank you for that, St. Andrew Primary. Anybody found it, you see it as adding and then multiplying? Anybody saw any other approach? How did you use the same strategy? Let me go to DuPont Primary. Tell me something. Is that what you did to find out what would be at the symbol?
So, Miss, you have to divide the 5 by the 20 and then add the 4 that you get plus the 5 would equal 9. And you do it, repeat again till you get the answer.
So you divided the digit at the left by the one at the bottom, right? So that was your approach. Thank you for that, DuPont Primary. So we're seeing that there are different approaches, but we're still arriving at the same result. So some said they first added, so they added something, and whatever they added to the number on the left, they then multiplied by that same number to get the number at the bottom right. Okay, so
I guess a little interjection here for DuPont Primary's response. They're actually dividing the 20 by the 5. So they would start from the
that's what I heard. Thank you for that, Miss. I knew that's what they meant, and in my head, that's what I heard. So thank you for that interjection, Miss. I didn't pick it up. Thank you. All right, so a number of persons have given their thoughts on it. Is there anyone who had a slightly different approach? Let me see if there's anything. Did you say anything in the chat? That's a different approach, Miss?
What I'm seeing here is the answer. Most persons have typed the answer in the chat.
21, okay. I'm seeing that as well.
And just as similar, you add, then multiply, but it wasn't so clear as to what you add.
Okay, all right. Thank you for that. So we're saying that we're adding, then we multiply. So what is it that what do you multiply? What do you use to multiply when you say you multiply? What do you multiply?
But let me add to you, Miss Harris. I'm seeing where trying to remember, is it Mona Heights Primary said?
I think Mona Heights Primary mentioned
9 subtract 5 equal 4, and then they use the 4 to times the 5, which we heard. Marlon Lewis, whoever, if that's a child or the teacher, they would have given it using some expression here, x plus 5 and then x times x plus y and then x times y.
Okay. All right. So where x is our first number, and y was whatever the I love that you're trying to generalize, and that's good. So trying to bring in a bit of algebra there. But
Miss, answer is D,
Okay, you raise your hand in order to speak. You can't just open your mic. Please raise your hand and we will identify you. Go ahead, Miss.
All right, so a number of you have already spoken to the answer, and the answer is indeed 21. So let's not talk. So how did we arrive at our 21? Let me see. Somebody, I believe, answered that we divided the 20 by, so let me see. See one, I'm not sure that is, let me see who else is here.
Miss, the answer is 1.
Do not open your mic and speak until you're acknowledged, please. Especially since the answer is not 1. And Mona, could you tell me why your answer is 21, how you arrived at your 21? Mona, put your hand is up. I'm allowing you to speak as how you got your answer as 21. All right. Is that they're having problems to unmute?
No, they are now ready to speak. Their microphone is open.
Go ahead now.
How I worked it out was I subtracted, for example, let's do the top one. I subtracted 9 by 5 and then I got 4. Then I multiplied 5 times 4 and I got 20. And then you can use that pattern for all of the others. So for number 20, what you would have to do is you would have to go into, so you'd
What?
have to divide 20 by 20, which is 1, and then you'd multiply 20 by 1, but then you would have to get, wait, no. So then you would add that 1 to 20, 1 which is going.
Okay, thank you very much, Mona. I love how you caught yourself and said, no, that's a part of growing. You pick up your mistake and you correct yourself. Indeed, you divide to obtain that. When you divide 20 by 20, we would get 1 and then we would add that. So we're doing, this time we're doing the reverse operations. We're doing the inverse operations in order to arrive at our answer. Very good thinking. You've done well on that one. So rather than add and then multiply, this time we have to divide and then add.
Okay,
Miss,
great.
when you plus the 1 to the 20, you get 21, and then you times it by 1 and you get 20.
All right, Fritz, thanks for that, but we'd have to think about that a little bit more, because I can't times 21 by 1 and get 20. But let's move on. We're now at question 3. Let's look at our third question. The table below shows the times done by 4 athletes in a championship race. The 2 fastest athletes progress to the next round. Now, before I even ask anything, what am I asking you to do here? What math concept am I asking you to apply here? Am I representing a quantity? Am I looking at a pattern? What am I doing here? Type in the chat. Am I comparing? Am I representing? What am
Miss,
I
you
doing
and
here?
I'm Blake.
I'm not asking for an answer. I'm asking you, what math am I using here? So don't give me any answers yet. What math am I using here? What will I use to decide on who is the fastest? Don't tell me the answers yet. What will I be using? We're not yet ready for the answers, students. What numbers with the lowest value? And Howard, thank you for that, Mona Heights Primary. Looking for the lowest values. I'm comparing the numbers. Thank you. Now you're talking to me. We're comparing the numbers. All right. And when we're comparing the numbers, where do we start? We're using comparing. Very good. Fine. Now we're together. We're comparing. But what do you notice about the numbers? All of them have the same. When you're comparing numbers, what strategy we use to compare numbers? When you're thank you, we're comparing the numbers. Fine.
Miss, we are division, divided.
Don't, boys and girls, please. Don't let me have to mute everybody. I can't mute myself. Don't just speak into the mic. You only speak when you're asked to speak. Mrs. Williams just reminded you of that. So without using a less than and greater than sign quite this time, but as I compare numbers, what would I do? I would start with the highest place value and see whether there's any that is the highest or the lowest, depending on whether no, are there any differences with the first place value? No, they're all 2. So that doesn't help me when I compare. Let's move to the next place value. So remember, when you're comparing, you're going to go place value by place value. So which 2 athletes will progress to the next round? Which 2 athletes will progress to the next one? I'll have to look for the ones. So I'm going to compare using the whole numbers. And it won't be, this time it won't be the 10th place because all of them are the same. So I'm going to move to my ones place. Looking at the whole numbers, the ones place tells me that I have 2 numbers that are less than 25. The 24.24 is less than 25. And then we have 2 that are more than 25 and another one that is less than 25. Fine. We want the 2 fastest. And someone had said earlier on that we look for the 2 lowest numbers. So remember that with times.
The answer is Johan.
Do not speak out aloud, please. Remember, we've said that over and over. We need for you to raise your hand and then we would, or you type in the chat. And many of you have typed in the chat already. And I'm thankful for that. Thank you very much. So we are saying that we want the two lowest numbers. We want the two that have the lower numbers, which are the two that are less than 25, which we see are Johann and oblique, because those are the two that are less than 25. Those are the ones that have values below 25. We don't even have to go to the decimal places, positions, because just based on the whole number values, those two guide us, and then we can go to the decimal values. Why is obliques time slower or faster than Johann's? Is obliques time faster or slower than Johann's? Slower. Thank you, Paul.
Go ahead. We're going to ask them to type that in the chat. Go ahead, Miss.
So you've typed that it's slower. How do you know that it is a slower time? Type in the chat again. How do you know that obliques time is slower than Johann's? Yes, it's slow. It is a greater value, and it is a greater value because the digit in which place? Tell me why it's a greater value. The number in the hundreds place. Excellent. I'm seeing some good use of math language. The number, or the digit rather, in the hundreds place. The digit in the hundreds place has a larger face value. So the 600s is larger than no hundreds. Very good. So the two athletes that will progress to the next round will be Johann and oblique. Great. So the slower one, so remember, if we were to summarize it, tell me, when you're comparing values, we take each place value rather. You look at the place value and you compare based on the face value of each digit in the given place value. So we have to look at that. So the correct answer would be Johann and oblique. Good. So the fastest time is Johann's, and then the next fastest is obliques. B, great. All right. So that's our third. Yes, Mrs. Williams.
Yes, Britain Primary summed it up real nice. They said this: the lower the time is the faster the athlete.
I did see that earlier up in the chat. Yes, the lower the time is the faster the athlete. Correct. We know the lower time based on the face value of the digit in each position. So the lower the face value, the smaller the value of the digit. All right. Now, here's another one. Here we're comparing again. Which number is closest to 1,000? All right. Before we jump to any answers, let's wait a minute. Always give yourself something time. Give yourself something time. Give yourself something. Whoa. I didn't even have the time to think. I'm seeing lots of A's in the chat. I see A and I see B. I see A and I see B. Okay. We'll see whether it's A or B. Let's talk about it a bit. Let's talk. How do I know how close a number is? How do I know how close two numbers are to each other? How do I know that? Can someone, before you tell me the answers, how do I know two numbers are close to each other? By rounding off? All right.
Excuse me, Miss. I think his answer is B.
Type in the chat, please. Don't open the mic just yet. I see some typing in the chat that by rounding off. All right, so you know a number is closer to a number by rounding off. I'd love to hear that rounding off discussion a little bit more. By subtracting. So let's take that rounding off discussion a little bit before we move on. Let me see who are the persons. You can round off. So with rounding off help us in this case. I could round off, yes. Let me hear some bit. Let me hear who was the first person who came with rounding off. Was it Brixton Hill? Can you see who was the first person who came with the rounding off, Mrs. Williams?
No, it wasn't Brixton Hill. I'll check to see, but we can move along until I find it.
I think it was Brixton Hill.
Okay. It was actually Monarch. I saw Monarch with that response.
Okay, in terms of the rounding off.
Yes, Liam also said rounding off. You can round off.
All right, so Brixton Hill was the first one that says by rounding off. So go ahead, Brixton, let me know what you meant by round. When you say rounding off, tell me about that. When you talk about rounding off, how will that help you to know what is closest to a number? can you unmute and let us hear that? When
Yes,
you talk
we
about the
can.
rounding out
They
to
are
know which
being
is...
asked just now to unmute. So go right ahead, Brixton Hill. I'm not sure what's happening, but they are actually not taking the response, the request
Okay.
to unmute. Let's move right along.
All right, let's move on. All right, then. I see also that Selamar said so, and then I also see Mona Prep said by subtracting. When you're subtracting Mona Prep, what are you trying to find? What's another, what would you be doing when you're subtracting? When I subtract, I'm trying to find what? Let me see if there are any other, by subtracting, by comparing the place value. Okay, rounding off, rounding off. Okay. So a number of persons are saying that they're using subtraction, and when I use subtraction, I'm actually finding in math we would describe the result of subtraction as what? So let me ask a question now. Can a number be closer if it is greater than the number? Can a number be closer to another number if that number is greater than the number? Is it possible? I see some person saying that I'm to compare the differences. I love that, Marlon Lewis. You raise that matter. I'm to compare the differences, and that's going to give me an idea of which one is closer. And I see some points in regard. So thank you for your feedback. You can round off, but rounding off wouldn't necessarily work in all instances. I would think that a more precise way, rounding off would work in some instances, but in this particular instance, it probably would not be the most appropriate way. So as someone said, I think it was, I saw a teacher or a student mention it there, you're going to be finding the difference because you're aiming to see, you need to know how far away from the given number the other numbers are. Well said, St. Anne's Primary. We need to know how far away, and we find that out by using the differences. So we could use the differences, but in this case, so if we did the differences, we could do that. We would see which one has the smallest difference, or we'd find out which one we're going to look at the differences. But this time we're going to use a number line. Let's look at the number line. First, we'd have to locate where the 1,000 is on the number line. So that's one way we can do it. We're locating where 1,000 is on the number line. Fine, all right. So we find out that 1,000 is at that position on the number line. What about, is there any other number you could identify the number line readily? Just type in the chat which other numbers I can locate on the number line readily. I can locate 998, yes. Is there any other number I can locate readily that is in my list of options? 990 and 998 are readily seen on my number line based on the options I have. So I can locate those two very readily. Thank you. So we have located those two. All right, and let me see now. Where would I locate 1001? Where would that be? Type in the chat for me where 1001 would be. In the middle of 1,000 and 1,002. So my 1,002, my 1,000 gives me an idea where my 1,001 would be. So it would be halfway. We can't just say between. We'd have to say exactly between or halfway between 1,000, 1,002. Excellent. Halfway between. Thank you for that. So be careful of not just saying in between, because I have to make sure that it's as close to halfway between as possible. So I can locate my 1,001. Great. And then I can locate my, so let's put in the 1,001, halfway between the 1,000 and 1,002. Then where would my 995 be? Give me that quick in the chat. Where would my 995 be? halfway between what and what? Where would my 995 be? Halfway between 994 and 996. Thank you for that. I see some responses telling us to be halfway between the 994 and the 996. Excellent. So we can locate our 995 and our 1001. Now, as we saw it, some persons mentioned it earlier on in here. So we're looking for the smallest difference, the one that is the smallest distance from the target number. Our target number is 1000. We're seeing which one is smallest distance away. So as many of you said, it is in fact 1001 because that is only 1 unit away from the 1000, whereas the others are further away than 1. No, 998 is not 2 digits away, 2 away, or 2 units away from the 1000, 2 units smaller, whereas our 1001 is only 1 unit away from the 1000. So we can all agree that our closest one is 1001. So notice that though the 1001 is larger, it is still the closest. It's fine for it to be more and still be closest. We have to be careful now that it's fine. Notice that in this case, the one that is larger is in fact the one that is closer. So look out for that. Remember that you determine the closest one based on the difference, the gap that is between the two values. Okay? So the smallest difference is obtained with 1001. Let's move on.
Hey, Miss Harris, I know you said let's move on, but as you have the number line here, they could also look if they are just using the number line. Once they locate the 1000, they could look to see at the distance from where the other number is. So you look at that, that's 1001. Let's compare the distance now of the 998. It's a bigger jump, as you can see there.
Right. So we did say that earlier on that one is just 1 jump away and the other one is 2. The smaller jump would obviously be the one that is closest. But thanks for the annotation, Miss. So we are all clear on that. So one of the biggest takeaways I want for most of us, sometimes we think that number can't be closest because it is bigger. Remember, closest looks at the difference in the numbers, the difference between the two values rather. All right, so we want to be very, very clear on that. Okay, thank you. So we can move on to our next one. This one again is about a bit of approximation, but now we want to be able to see. So which of the following is the best approximation of the location of P on the number line? Take a moment, look at the options we have, and look at where P is. Look at where P is. Examine the position of P on the number line. Give me an idea. What can you say about the position of P on that number line? If you were to think of, what can you tell me about the position of P on the number line? Type in the chat anything that you see about P in the number line. I'm not ready for the answers yet. Type in the chat and tell me please. Type in the chat anything you can tell me about the point where P is at. Thank you, DuPont Primary. You're answering the question asked. I didn't ask for the correct option. It's more than halfway between 2 and 3. Excellent. Good answer there. So I'm not asking for the answer to the question, boys and girls. Do not jump to the answer. We're going through our process of discussing how we arrive at our answer. I'm not saying whether it's A, B, C, D, or even F. Well, there's no F or G there. So I'm not ready to unmute anyone yet, so I'm asking you to type in the chat, please. One school has already, it is close to a half. One school, I think it's DuPont, mentioned that it is more than halfway. It's 6 out of 10 spaces. So you're saying it is in the 6th space of the 10. All right, 1, 2, 3. Just use the laser pointer from please, Mrs. Williams, to show where we can highlight that it is in the 6th space of the 10. So it's in the 6th space of the 10. 1, 2, 3, 4. So as Jesse Report is saying, it's between the 6 of the spaces. Fine. Thank you for that. And I love how DuPont used their benchmark of the halfway, and they said that it is more than halfway between the 2 and the 3. So that means that, as I've already established that use of that benchmark, it is more than halfway. It tells me that anything that is less than halfway, would I choose that? What does that tell me for my options then? It's more than halfway. Thank you. That's a good start.
As you said that, Miss
halfway.
Harris,
Yes?
let me just share what Stella Maris has put in the chat. It is not directly halfway between 2 and 3. It is closer to 3. And then Jesse Paul responded by saying it is after half.
Yes, I thank you for that. DuPont was the first school that responded with that similar response, that it is more than halfway. So it is not half, it is more than halfway between the 2 and 3, but it is closer to the 3. Thank you for that. So it is closer to the 3 than the 2. So thank you for those two inputs, that it is closer to the 3. It is past the halfway mark. But is it closer to the halfway, or is it closer to the 3? That's another thing you have to look at. Remember that when you think of is it closer to the halfway mark? Or is it closer to the 3? Those are some of the things we need to ask ourselves.
So the response that came from Bridget Williams' strong students is that it is more than halfway, but it is closer to the 3.
It is closer to the 3 than the halfway mark?
That's what they have responded.
That's what they're thinking. Okay, yes. Thank you for that. So I'm not yet ready for that. We are processing the values that are here. So we know that but I would like us to look more closely at that. It is not closer to the 3 than the halfway mark. Be careful of that now. Can you use the pointer for me, please, Mrs. Williams? Look at where the 3 is and look at where the half is. Let's look at, how do I know?
So this is the half right here.
That's the halfway mark. So our P is closer to the halfway mark than it is to the 3.
Which is all the way over here.
So 3 is all the way over there. So be careful with that now. So we can move on, miss. Let's look at this now. So let's identify our halfway mark, and then we can look at something else. We have our halfway mark there. That's 2.5 as a mixed number. 2.5, we representing it as a decimal number. So it's a little more than a half. We can see that. How do I know when a fraction is close to a half? How do I know that when a fraction is? So we're looking at strategies now. How do we know when a fraction is close to a half? All right. I see some other discussions coming up in the chat. I wouldn't choose. So before we go there, halfway tree primary, how do you know that the 5, 6 is so close to a whole? I'm going to rephrase my question to halfway tree primary and take it in another angle. Halfway tree primary, can you tell me how you know when a fraction is close to a half? Are you able to tell me that? Are you able to unmute and tell me that? See, Mrs. Strong, William Strong class. And
so halfway tree primary, you have been given the request to unmute. Kindly unmute. There are many devices that are on, so we're getting a feedback.
Right, so we can't use that one. Yeah. All right, Ms. Richard, can someone tell me how I know a fraction is close to a half? I'm not ready for the answer yet. The question I would like to have answered at this point is, how do I know that a fraction is close to a half? St. Andrew, your hand is up. Go ahead and tell me how you know that a fraction is close to a half.
That's St. Andrew Prep. You can unmute now.
How do I know when a fraction is close to a half?
We
we know the fraction is closer to the half because when counting, it is split into 10 equal shares. And we know that 5 is half of 10.
Okay, thank you. All right, so that is for this fraction. So can Mrs. Williams, Strong class, let me thank you for that input, St. Andrew Prep. I'd like to hear from you though, and my students, how do you know when any fraction at all, anyone at all, how can you look at a fraction and be able to tell when it is close to 1/2?
I'm
Okay,
seeing several raised hands in the chat. Would you like me to choose one of them, Ms. Harris?
Yeah, I'm seeing that one narc is one narc would like to unmute and say how you know it, how you identify that the fraction is close to 1/2.
So 1 hour, please, one person speak. Once you open your microphone, one person speak. All right, so they're not coming through there. So we can move on, right? It's not coming through clearly at all.
No. I gather that DuPont, I'm seeing a colleague remind, DuPont made a point that A and C are way off. And I'd love for us to speak to that. A and C are way off. And I love how they've put that. Maybe I'll just, in the interest of time, I'll just speak to that. And you're spot on right in your elimination on that DuPont.
May I add?
C,
so DuPont, sorry, go ahead.
A and C are way off, and they're good at, that's a good process of elimination. Why? Because A, which is 2 5/100, is way down near to the 2. The P is far away from that. So Miss, could you just use the laser pointer to show where 2 5/100 would be roughly, please? So 2 5/100 would be way down near to the 2.
Let me close this so we can get to it.
2 5/100 would be way down close to the 2, which is far away from that P. So that's way off. I quite agree with that.
2 5/100 would be all the way down.
All the way down close to the 2, very close to the 2. Even that is about 2.05. 2.05 will be halfway between the 2 and the 2 1/10. There you go. So it's way down close to the 2. That's good. Very good. 1 1/4 is not near to 1/2 either. So we're looking at the number line positions. Very good. I want for you to give me an idea now of how I can look at a fraction and know that it is close to 1/2. I don't want to change anything. I don't want to do any manipulation of the fraction. I want to look at it. I don't want to form equivalent fractions. I don't want to do any manipulation. Let me see. You can form equivalent fractions by dividing to see the number is close to 1/2. Okay. I see some responses. All right. In the interest of time, no, I don't want to answer the question for you. Mr. Primary, I see your hand up. How can I tell when a fraction is close to 1/2?
Ms. Harris, if you would allow me, DuPont responded to that question earlier in the chat. The response was, you know that a fraction is close to 1/2 when the numerator is half the denominator.
All right, I didn't see that in the chat, so thank you for that. I see Almontown has that. Almontown has it. Almontown said it, yes, when your numerator is close to half of the denominator, or let me put another way, when the numerator is close to, thank you, Almontown, I missed that in the chat. So you did come out of the blocks on that early. Thank you for that your numerator is close to half of the denominator. The point came in afterwards on that. So we're saying that we look at, I flip that another way. When the numerator is half of the close to half of the, could I flip that another way and speak in terms of the denominator? Since we name fractions based on the denominator, how could I say it using the denominator? How could I use it how could I talk about knowing the fraction based on the denominator? Would anyone like to speak to that? Fractions are named based on the denominator. So thank you, Mona Heights Prime, when the denominator is almost double the numerator. All right, so students, look at those strategies, please. We don't always have time to do calculations, but we can eyeball something and learn the strategy of using benchmark fractions. So we're saying that once the numerator, not the numerator, we name fractions based on the denominator. So let's talk about it from the denominator end. Once the denominator is just about twice the numerator, then it means that my fraction is close to a half. If it's slightly more than twice or slightly less than twice, it means that I'm close to 1/2. So when the denominator is just about twice the denominator, when the denominator is just about twice the numerator, then we thank you for that. So Edison has also typed that in the chat. Excellent. So we want to be able to use those strategies. We don't always have time to convert to equivalent fraction and multiply numerator and denominator by the same number to form equivalent. We have to look for strategies that help us to move quickly and efficiently. Beautiful. Let's move on. So where would we? A number of you have said it. So A is out, B is out, so is C. So obviously, close to a half of the denominator is close to twice. It's close to a half. The denominator is close to twice the numerator. We've said that. So let's move on. So what would be our correct option then? Our correct option would be option D, 2 4/7. Great. Next question. Let's move on. So remember, we don't always have to convert to those equivalent fractions. We can use. All right. So we're not using the time now to cross chat. So let's move on. Are we ready now? So remember, let's look at our next question. The table shows Maya's 3 attempts to unlock a device using a 3-digit passcode. For each try, the table shows the number of digits that are correct and the number of digits that are in the correct position. So there are 2 aspects being looked at, whether the digits are correct and whether they're in the correct position. Take a moment and look at the table, boys and girls. Take a moment and look at the table. Because our question now to you is, taking the table a little bit. All right. All right. So I see answers in the chat already before I even put up any options. But what is not DIS? Can you imagine? Okay, Miss Berry's class, let's hear how you arrived at the 7,553. Are you able to unmute?
Whose class is that, Miss?
Charlene Berry's class. I'm not sure which school she's from.
In a short while, they'll be able to unmute.
Let me see if her hand is raised. I don't think her hand is raised here.
But they have been given the option to unmute. So please take the request. Please unmute.
Miss Berry's class or Mrs. Berry? I'd like for you to walk us through how you arrived at her 753 before we move on.
So, Ms. Harris, they have not taken the request. Perhaps we could move on to another school. I see Rockall Primary.
Rockall Primary has their hand up. Go ahead, Rockall
you may
Primary.
Unmute.
Rockall Primary can unmute and answer, please. All right, we're still not getting any answer on that one. Okay. I'm seeing lots of D's. I'm not seeing any other. Do you see any other raised hands in the chat, Mrs. Williams? I want to see from a school that hasn't spoken yet.
Right, so I'm seeing Rock Hall Primary. I've given them the prompt to unmute, but they have not yet taken it. I'm going to move on. Once more, Rock Hall Primary. Please unmute and share. All right, so we're moving on to another school. Let me see who else has a raised hand there.
Mona hand is up. Also, can see if there are any new hands, but I'm not seeing any new hands. So the next one in line was Mona.
All right. There is I think you wanted to hear from Bridget Williams Strawn. They are
Is her
here.
hand up now?
Yes.
Go ahead, Mrs. Strawn's class. Go ahead.
Please unmute. I'm not sure what's happening, but they're not taking the prompt or the request to unmute.
Can you unmute, please, Mrs. Williams, and answer? You're not able to unmute, Mrs. Williams Strawn?
Miss, the answer is C. C.
Okay, you think it's C, all right? Tell me how you arrived at your C. You need to take time. Just tell me the answer C now. Remember, students, once you tell me an answer, you need to be prepared to say why you have that answer. How did you arrive at that answer? I see several answers, several having D in. You're saying C, but you're not telling me why you arrived at C, and let's think through whether we agree with you that C is our correct option, that C is the passcode. But allowed that. Who is the next person that is in line? I wanted to allow some other hands, but I'm not seeing any different hands. You're seeing any new names there, Mrs. Williams? I think I see Miss Robinson. Which school is Miss Robinson from?
You're seeing Miss Robinson?
Yeah, Miss Robinson is a little lower down from Mona Prep and Jesse Paul.
Or Robinson. All right. So we're going to ask you to unmute. Please, when you get the prompt to unmute, please take it. You're now asked to unmute. Go ahead, Miss Robinson's class.
The answer is D, 753.
Could you tell us why?
Miss, because in the answer 154, it says the number of digits correct to 1, number of digits in the correct position, and it said 5. So you know that 5 has to be in the middle, and it says number of digits correct in 713. It has 2. Number of digits in the correct position 2. So you use the 7 and the 3 and the 5 from 154. So that's how I arrived at 753.
Okay, thank you very much for that. And if everybody any challenges with that reasoning from Miss Robinson's student?
So one thing she didn't say how she decided
on the 5
is the correct option. So a little bit, unclear, but we see her response.
Okay. Let me see. Anyone use another approach? Let me see if we come down some more. Is any others that were new hands, Mrs. Paulette Barrett? Is that Mountain View Primary?
Perhaps we could hear from Jesse Ripoll. They have
Jesse
their
Ripoll
hand
is high
raised.
up. Okay, let's hear Jesse Ripoll and then we go ahead, Jesse Ripoll, if you can unmute.
So, Jesse Ripoll, you've been given the request to unmute. Kindly do so and speak.
Hello.
Good morning. Go ahead.
We think our answer is D, and we would like to tell you our reasoning behind it.
Go ahead.
So in the first try, 2 digits are correct, and 1 is in the correct position. We couldn't really get anything from that, so I went to the second one. 1 digit is correct, and 1 is in the correct position. Again, we couldn't get anything from that. But on the last one, 2 digits are correct, and 2 are in the correct positions. Now, remember from the first one, it said 2 are correct, and 7 and 3 are in both the first and the third try.
but this time 7 and 3 are most likely in the correct positions. And since now that we know that 1 is not the correct answer, we can see that in the second one that 5 is the one that's in the correct position. So I think our the answer is 753.
Okay. Thank you. So thank you for that contribute. I want to ask something. So no, let me not spend too much more time on. Do we have no? Okay. Thanks for other any other different responses. Juanito. Okay, so Miss Robbins from Don Robin Primary School. Okay. Thank you for those inputs. Our strategy, should we share our strategy? Yes, we could share our strategy. Can anyone tell me why 173 option A is out? Why is option A not one? Why is 173 not a correct, not the passcode? I'm looking at why the A is not the passcode based on the clues that were given. Our person is ready to answer that question, why A is not the passcode. Why is Telemar script? Why is A not the passcode? Not going to spend a lot more time on this because we need to move on. So, all right. So I like the expression, the explanation that you gave from was my Jesse Report student, walking through the 3 tries and what we can deduce from the 3 tries is good. I wanted to hear even one person tell me why 173 is not a good option. But go ahead. Liam, I'm seeing your name is not the first time I'm seeing. Liam is from which school? All right. Mrs. Williams, could you allow Liam to unmute?
Sure. Liam, you are given the prompt to unmute. Kindly unmute.
Oh, his hand isn't up anymore.
Liam from Don Robin, miss.
Go ahead, Liam.
So the reason why it could not be A, miss, because for the first try, it says the passcode was 731, and the number of digits that were correct will be 2, miss, and the number of digits in the correct position were 1. So when you go to the second one now, the third one, I should say, it says the number of digits that were correct is 2, and the number of digits in the correct position is 2. So the second one now is saying the number of digits that is correct is 1. Number of the digits that is in the correct position is 1. So what I picked up.
That's not what she asked you. She's saying why is A not the correct answer?
Thank you, Miss.
Correct answer.
That's why I'm smiling. Thank you very much, Miss. I wanted you to tell me why is it that 173 could not be the passcode? All this is the question that's being asked to students. Why is it that 1 cannot be the passcode? All right, I think we're taking a little bit too long. So I'm gonna just say,
Miss, could I say something?
Go ahead, Miss. Which school is that?
Brixton Hill Primary and Infant.
Go ahead, Miss.
Yes, Miss?
Yes. You can go ahead.
Go ahead. I want to hear why 173 is not an option.
I did not say 173 is not an option. I'm going to explain something here, Miss. All right, when I look at the first, I'm seeing 731. Number of digits correct 2. Number of digits in the correct position 1. Well, we cannot use that to analyze everything. So we went to the second. It says 1 number of digits correct. Am I correct? So when I look at 731, I'm seeing 1 common in both. So therefore, 1 must be one of the number. And 1 is in the first position. I go down to the third. I'm seeing 713, number of digit correct. And number of digit in the correct position, which is 2. And as such, since 1 should be the first number, it should be 173. Correct me if I'm incorrect, miss. That is how I analyze it, or my students analyze.
So your students are surmising that 173 is the correct passcode?
Yes, miss.
Okay, so let's look at it now. 1 digit is in the correct position in the first one, the first try, correct?
Yeah, yes, miss.
Okay, so if 1 digit is in the correct
in the
position,
first, you have 2.
No, 1 is in the correct position.
Oh, yes.
Okay, so if 1 is in the correct position, 1 digit is in the correct position in the first one. Let us look carefully now. Is 1 in that position in option A?
I'm not hearing, miss. Is 1?
There's only 1 digit in the correct position in option in the first try.
Yes.
Okay.
So we cannot use that. You have to move on to the second.
No, hold on now. My question was, why is it that we eliminate? Is 100? Is 1 in the same position in option A as in the first or the third try? Option A is 173. So my question is, I'm saying we can rule out option A.
No, but the thing about it, miss.
Miss, allow me to finish, please. Just allow me to finish. The reason we can rule out option A is this. The location, the position of that new digit 1 does not match any of the digits, any of the positions for the first try or the third try. And in both of those tries, there's at least 1 digit in a correct position. The position of the 1 in option A does not match any of those 2. So since the position in option A, which is in the 100 space, do we have 1 as a correct position in the first one as 1 is not in the position of 1 in the first try and option A? That alone tells us that it can't be correct. Because the 1... So, miss, let me see if I can, and colleagues, if you can help me out,
I'm not contradicting you, miss, but I'm just saying, when I went to the second one, it said 1 is in the correct position.
It did not say
so
1
that means
digit.
1 comes in first at the second one, because that's the only one that is...
Please. Nice to be here, miss. So, based on what Miss Harris was saying, the first code, the first passcode, the information given is that 2 digits are in the correct position, or 2 digits are correct rather, but 1 digit is in the correct position. However, when we look at option A, we are seeing 1 in the 100 place, but when we look here, 1 is in the ones place. That's not enough information. 2 digits are correct. It could be 1, it could be 7, it could be 3, any of those, two of those, all right? But let's move on to the second option. In the second passcode, it says 1 digit is in the correct, 1 digit is correct, and 1 digit is in the correct position. If you look, 1 is the only number from the first try that appears in the second passcode here. They are in different positions. Let's now move on to the third try. The third passcode says 2 digits are correct and 2 digits are in the correct position. Now let's look back. Coming from the first code with 2 digits in the correct position, we see that the 7 has returned. It's a little long, but the 7 has returned in the 100 position. That's one thing. It has returned in the 100 position. And then we're seeing also that 1 is in a different position as compared to the first passcode. It's in a different position. It's in the 10th position here. but the ones position there. So when we look at it, look at the numbers coming down. For A, it's not showing 7 in the 100th place. Neither is it showing 1 in the 10th place, and not even in the 1st place. So that's ruled out clearly, right? You want to also look at this same A here. Let me just stay on the A a little. All 3 digits that appeared in the first code are here in A. And the fact that it said only 2 digits are correct and 1 in the correct position can't be correct if it has all 3 digits. That's one of the reasons for ruling out A. So let's continue now with our reason. Still at the going back to the third option here with 2 digits in the correct place. 7 has returned. And then we still have the 1 and the 3, which is from the first code. But when you look at the second try, we are seeing that 1 is in a different position from where it is in the third try. So there, it could for me, I rule it out to say that is not the digit that is in the correct position because they are now different. So I'm moving on. I'm looking for 5 and 4 now. 5 and 4 were not in option 1 or the first passcode. So looking at it now, I'm seeing that 3 also, since I ruled out 1 wasn't correct, 3 would have been the next code, the second code that is correct. So we are agreeing that 7 is correct. And now 3 would have been the next one that's correct. And so the fact that 1 would have been in different places all along and it's just not correct, you can see it's in 3 different positions. First it was in 1s, then 100, and then 10s here. We know that it is not the correct digit. So that has been ruled out. And so the next digit that would have fallen in place, if 7 and 3 are in the correct place, would be the digit 5. Hence we come up with the answer 753.
All right, so the explanations, I'm gonna ask my Jesse student just to quickly help this section. Was it the Jesse student who gave us the explanation at the very start?
Yes, it was the Jesse Repole student.
The Jesse Repole student gave a nice succinct answer. Miss, are you seeing now why 173 is out? Are you better now?
She might not be able to unmute, but
you can just type in the chat if you're clear as to why 173 is not a correct option.
But just to sum it all up, a good way for her to see that 173 is not the correct option. Based on the first code, it says 2 digits are in the correct
She's fine now. She's fine.
Okay, great. And so all 3 digits appearing there would not make it the correct option. All right, go ahead, Miss.
All right, so our students, are we all clear now as to why we have chosen 753? Because we know 173 is out because it cannot be because only 2 digits are correct. So let's thank you for all the input there. Just Repole gave one of the explanations, and I'm sure a number of you are clear now as to why we're at where we're at. So our correct option is option B. And remember now that we are based on let's move on. Based on the third one, we can know that the 1's place has to be a 3. So we move on. Go ahead, Mrs. Williams. Thank you very much.
Thank you too, Ms. Harris, and thank you, students. We love the participation, and we are almost there. We're almost nearing the end of our presentation, but we have a couple more questions that we want to share with you. So keep the participation going. So thanks again, Ms. Harris. So we are moving on to question 7. Question 7 says, Wendy attends football practice every week. The table below shows the number of goals she scored over a 5-week period. I'm going to ask you to just look at the table before we reveal anything else to you and look to see if you can just tell us what you notice. You can type it in the chat. Tell us what you notice. I would love for you to tell us what you noticed. Don't give us any answer. That's one of the reasons why we have not revealed the options as yet. And while you're doing that, I am going to ask you, if you join us late and you are not able to register, The registration link is posted in the chat. Kindly click on that link and register. This is vital information for us as to how we can serve you better the next time around or include you in our workshop. So go right ahead and click on that link. I am seeing in the chat from Mother Sil, every other day she gets 1 or 2 goals more. You want to look at that. Look at the key, Miss Mother Sil or Shanice Mother Sil. Look at the key, and then that will help you to fix that up some more. For those of you who type the answer in the chat, I'm going to bypass that. So yes, the link is there. Someone said each total is a multiple of 4, but that's good information for you to observe. So thank you for that observation. And I'm seeing, I wish that person could change their their name or what their device is named at. There is a sequence of 1, 2, 1. 1, 2, 1. And it will be, it's so important if you're talking, you could tell us if you're talking about the number 1 or score or goal or ball, whatever. Be a little bit more specific. All right, thank you so much. So each week, Stella Marie said, each week the number of goals increased by 4 goals, then 8 goals, and repeat. All right, I think I have, as the weeks progress, the goals she scored increased. That's from Liam. But thank you so much for that, Liam. That's a little general. You'd have to say by how much it is increasing. And the final one I want to point out is Paul Mountain Primary. Paul Mountain Primary says each week she's improving by 4 or 8 goals. All right, so let's move right along. Those are some very good information and some very good observations that you have made. Now, the question is, if the trend continues, how many goals will Wendy most likely score in week 7? And that's the reason why what I want to point out here now is the answers that were coming in the chat. I am not sure how you were able to give me an answer without the question being revealed. We want to caution you, boys and girls, that you must read through every bit of information first before you come up with an answer. Very, very important. So one of the first things you want to do when you are given information on a table, if there is a key or legend, you need to observe what that means. We're seeing here that one of those balls is equivalent or equal to 4 goals. And so we can use that information. So I want to ask you now, boys and girls, what strategy can you actually use to help you arrive at the number of goals that were scored or would most likely be scored in week 7? One strategy that we would like to share with you is that you can use a table to outline the information given. So let's put that there. Or you could just use the same table, but because we want it to be clear and nice, we have drawn a different table. So we're seeing that 1 in week 1, that's 1 ball there, and that represents 4 goals. So let's move on to week 2. Week 2, we are not seeing just 1 ball, we are seeing 3 balls. And so if you ask me, I could ask you, before I ask, the number of goals would be 3 times the 4, which is equal to 12. And then in week 3, we are seeing something also that is not 3, and it's not 1, but it's now 4. Now the question is, and you keep putting in your numbers to help you. So here we go to week 4 because that's given. And we're now seeing 1, 2, 3, 4, 5, 6. So you by now you should observe something. Let's go to week 5. And we are seeing that there are 1, 2, 3, 4, 5, 6, 7 balls, which is 7 times the 4, giving us 28 goals. What's the pattern? Have you observed anything? I'm seeing. All right. Okay, I'm still seeing answers, you know. I'm seeing answers coming in. I haven't seen a pattern yet. But based on what, okay, I see from somebody, I see add 2, then 1, and repeat. Add 1, then 2 balls, and repeat. Let's pay attention to that. And that's something you actually want to do. So here we have 1 ball. And then here, the 1 ball returns, but alongside it, there are 2 other balls added. When you go back, when you move on to the 3rd week, we're seeing that the 3 balls came back, but here, 1 ball is added. So that's an additional 4 balls. Let's look at the pattern as we move on to week 4. We're seeing that, again, the number of balls from week 3 would have, our number of goals from week 3 would have now returned, and 2 added, 2 more balls added. And if we continue down to week 5, we'll see that the number of balls have come, but they are now adding 1. So you want to ask yourself, what is the pattern? So first of all, we have 2 balls added, and then 1 ball added. Here, 2 balls added, and then 1 ball added. That's how you come up with your pattern. Just observe and see if something, notice what is different, what is same, and then you're able to say what that rule is or what that pattern is. So let's make the revelation. Yes, we have observed the pattern. The first one is that the fact that 1 ball is there, only 4 goals. Now for the second one, you're observing that 2 balls were added, so that's now 8 more goals, since 1 ball represents 4 goals. And then we have 1 ball added, which now represents 4 more goals. And looking at week 4, we're seeing 2 more balls added, which is actually 8 more goals. And if we continue for week 5, 1 more ball added, it's 4 more goals. So what would be the number of balls that would be added for week 6? That in the chat. What would be the number of balls that would be added for week 6? Just write week 6 equal, and you say the number of balls. Week 6. All right? The number of balls that will be added. Just the number of balls that will be added. Anyone? Not the total. All right? I'm seeing for week 6 that 2 more balls will be added. So let's reveal that. So quickly, we have 2 balls will be added, and that would be 8 more goals. And if you continue the pattern, we are seeing that for week 7, that would be how many balls will be added, or how many goals would be added for week 7. So if the pattern is 2, 1, 2, 1, and then 2, it will continue in that form. So there we have it. 2, 1, 2, 1. So in the 7th week, there would be 40 goals scored. All right. So make that revelation quickly. All right. That one, you have been doing patterns, and so you would have seen that one easily. But remember, I want to caution you, do not seek to give an answer before you read everything that's given. Let's look at another question. Now for this one, we're going to be analyzing data. And that's another of our category in our PEP quantitative reasoning. The pie chart below shows the distribution of 1,000 students and the grades they are in. Which of the grades shown in the pie chart has about 250 students? The first thing you want to ask yourself from this pie chart that is shown is what information is given. Quickly look at it and tell me anything that you have noticed. Have you noticed anything? Have you noticed anything? I see where Jesse Paul is using their percentage to say 250 is 25% of 1,000. All right, thank you for that response in the chat. and halfway through primary, you are saying it's grade 4, but please tell us what you have noticed in order for you to say it's grade 4. And a number of responses are coming in the chat. All right, so let us guide you through it. Again, the information given. What math do you need? That's the question you ask yourself. What math do I need to solve this problem? One of the things that you can use from a previous question is benchmarking. So once you know the relationship between 1,000 and 250, which was revealed by Jesse Ripoll, if that is a quarter or 25%, fine, then you can now proceed. You can use benchmarking of a half. What's a half of 1,000? Quickly type that in the chat. I know that's a quick blow up. I'm taking it from there and then I'm narrowing my way down to the 250. Wow, and I see a number of working out there. So I see 500 is a half, and that's a good way to put it. So we could identify it. You can use up your number line. We're using the different strategies. Use up your number line here, and you locate, you put on your 1,000, locate that half mark, which is 500. And we ask what percentage is that, right? So 500, which is half of 100. What is half? As a percentage, and that would be 50%. If you look, you're seeing grade 2 being that school, that grade that is shaded in red. And clearly the 47% is very close to the half mark, so there's no way it could be it. You could also ask yourself, what is a half of 500? Because we want to get down to the 250. We're looking at the relationship. And here I am putting the half in another direction or another position on the pie chart. As you can see, it's diagonal. Let's half that now to find a half of the 500. And there we have it. And what percentage would that be? As well as look on the arrow on the number line, you will see what the half of the 500 is, which would be smack in the middle here, which would give us where our 250 would be. And as you have safely said in the chat, that 250 is 25% of 1,000. Thank you so much for that. And so right away, without doing much of a calculation, I am actually seeing where the 250 would be. And we can look and see that. Let's go to the others. Let's move right here. As you can see, this is a quarter of the 500 or the half mark that was shown. And here we have a grade or a color that represents a grade that is in this. But look at it. It is actually 26%. And that tells us, notice the question says, which of the grades shown on the pie chart is about, meaning that you're approximating. And by right, you have placed that in the chat. So yes, you are correct. It is grade 4. Let's move right along now. So look at question 9. Use the diagram shown to answer the question. Again, we are to identify the information given. Now go ahead and type in the chat what information is given based on what the pie chart is showing. So what information? So use the diagram shown to answer the question below. If 7 students traveled by bike, how many children were there in all? What information is given? Let's go to the chat. Now I'm going to take the response from Jesse Ripoll in the chat. Bike is a quarter. Excellent. There's a reason why I'm not taking the other answers, because you are giving me the answer to the question. What do you notice? Again, Jesse Ripoll says taxi is half, or taxi is represented by half of what's there. I'm going down now to see if anybody else or any other school would have put what they noticed in the chat. All right, so let's move right along. Hopefield replied by giving the answer. So let's move right along, because you will seem to get this. Again, you look and say, quarter of the students travel by bike based on our chart here. That's what it's showing. And that quarter represents 7. If you look also, another bit of information is there's another quarter that's shown by bus and walk. Persons who travel by bus or either walk, that's another quarter. That's another 7. So right away, that's an easy solution for us. We can now say half of the students traveled by taxi, which would now be the 7 plus 7 or 2 times 7, giving us 14. But now the question is, how many children were there in all? And you got that from the outset. So there we have it, 28 students when you add those numbers that were seen on the pie chart on the previous slide. Let's move on to another question. Question 10. Now, the question says, Digicel mobile service charges a monthly fee of $20 plus 15 cents per minute. Marvin's monthly bill is $31.25. How many minutes did Marvin use? Let me give you some think time to think about what's there and how you would come up with the answer. But you see, as you're thinking, I want you to now tell me what information was given. So let me allow you to read it for yourself and pick out the information and tell me what information is given. What information is given? You can raise your hand if you wish to speak. Say what information is given in the question, or you can go ahead and type it in the chat.
DuPont has mentioned that the monthly fee is $20. And
very good. That's one bit of information.
The monthly fee, somebody else is also saying the monthly fee.
All right, so we're given the monthly fees. Thank you so much for that. One art, if you have a different response, then you can keep your hand up. If not, please lower your hand. All right, so
what else says that they give the rate per minute or the price per minute?
Awesome. The rate per minute is given. Excellent.
Rate per minute says monthly fee, charges per minute, and the monthly bill.
Excellent. Thank you so much for that. So definitely we applaud you for observing that. So yes, the monthly fee is $20 and it's 15 cents per minute. Another bit of information that was given is Marvin's monthly bill. So what math do we now need to solve for the answer to find out how many minutes were used by Marvin? Is there anyone who would love to share that? How would you work out or solve for the number of minutes that Marvin actually used? Anyone? Let me check quickly. I'm just going to the chat to check.
The chat has some answers, Mrs. Williams. So just recall, share their 11, well, it's had 11.25. 11.25 divided by 0.15. Another student said subtraction and division, but not so clear which one it meant. Okay. Division and subtraction. So just the most precise one is $11.25 divided by 0.15.
Right. Thank you so much for that, Miss Harris. All right. So I didn't get anyone to raise their hand to actually
Stella Maris's hand is up.
What is their talk? What is their thought here? Stella Maris would love to. All right, go ahead and unmute. We'll give you a chance. Go ahead now. One person speak. Go ahead. Thank you, Stella Maris. You're unmuted. Go ahead and speak now.
So first, I analyzed that Marvin's monthly bill is $31.25. Digicel mobile service charges a monthly fee of $20 and plus 15 cents per minute. So first, I subtracted $20 from Marvin's monthly bill, which is $31.25, leaving me with $11.25. Then I divided 15 cents into $11.25, leaving me with 75 minutes.
Okay, thank you so much for sharing, Stella Maris. Well said, and you would have done a very, very good job. So definitely, based on what you were saying, when you subtracted the $20 from the $31, I'm going to put some perspective here into place. You're finding the difference between the monthly bill and the monthly fee. Please bear in mind that the monthly fee means that is constant. You pay that continuously. Every month, there is a charge, a monthly charge of $20. So that aside, then you will be the amount of minutes that you would have used, or Marvin would have used, would have now been multiplied by 15 cents or by 15 and then added to that $20. You're right on spot. So for the cost now, for the calls, it would be, once you find that difference between $31.25 and the $20, just like Stella Maris said, you now work out how many 15 cents we have in the $11.25 by dividing. Thank you. And remember, if you notice, we're dividing $11.25 here by 15 cents. We're dividing by a decimal. Our divisor is a decimal. So we must now do some changing here. Change the decimals to whole number. How do we do that? We multiply by a power of 10. In this case, we're dealing with dollars, or we could say we have two places of decimals. So you multiply by 100. And whatever you multiply the divisor by, you also need to multiply the dividend by that number. So in this case, we're multiplying the divisor and the dividend by 100. And that would give us 1,125 or 1,125 divided by 15. And like we heard earlier, 75 minutes is the correct option. So let's reveal the slide with the options that were given. And here we have it. 75 minutes is the correct answer. Boys and girls, we're almost at the end of our session. This is our final question. However, before you go, let me quickly do a summary of our quantitative reasoning. We want to encourage you as you go into the exam, not only for quantitative reasoning, but for all the areas, the verbal reasoning for your PEP ability, as well as for your CBT test. Please ensure that you read the instructions carefully. Read your questions more than once to find out the information given. That's why we say read the question thoroughly. Having read the question thoroughly, see what information is given. Look also and see if you can observe a pattern of some sort. Along with that, you now decide on the skills that you might need to solve, the process that you're going to need, the strategy that you're going to need to solve. For the answer, you could use your tables, you could use your number line, you could use your benchmarking, along with a number of other strategies that you would have learned. The thing is, you need to pull on what you would have learned and use that for the given situation to come up with your answer. Then you move on to answering the question. Like Ms. Harris had said in the initial stage of the presentation, that you must now check your answers for reasonableness and to see if it really is in the option given in the case where options are given, or if it makes sense to you. Having done that, then you know that you are going to